Hello everyone, this is your tutor AB and today we're going to be solving a problem from the November 2021 Mathematics HL examinations. This is a paper 2 question and it's an additional higher level problem. It's worth 8 marks with part A being worth 3 and part B being worth 5. So let's solve it. This is relating to differential calculus. So let's solve part A. I'll copy paste B when we need it later on because we're definitely going to take more than what's the area on the screen. So part A, show that dy by dx plus x times plus in brackets x times dy by dx plus y times 1 plus ln of xy is equal to 1. Now that looks like a monster of an equation, but it's doable. Let's check it out. Okay, so we're given this standard equation. Let's differentiate it, right? They're asking us to differentiate, so let's differentiate. We have to differentiate both sides of the equation, so d by dx of y just becomes dy by dx, that's implicit differentiation, and that's equal to, we differentiate x, so we'll say d by dx of x, and then here, if we take a look, right, we have, let me write it up here, x, y, ln of xy. We would be using a product rule, right, but there's 3 terms here, right? A product rule is x times y prime plus y times x prime, but in this case there's 3 terms, so what we're going to be doing is going to be x y z prime plus x y prime z plus x prime y z, right? Because we have 3 different terms to differentiate using product rule, we have to use this product rule variation. So what I will do, right, I will just lasso this formula up here so that we can refer to it as we use the product rule for this question. Okay, let me just say what it is. This is just product rule for 3 terms. It's not really often that we see this type of product rule for 3 terms, but if it did happen in this case, so it's not anything too crazy, but we just have to remember that this is what we have to do to differentiate this xy ln xy. So let's apply it, shall we? Let's say minus, let's put it in a big bracket, we have to keep x, keep y, differentiate z prime, and if you don't understand already, x, y, z, I'm just using them as placeholders for their actual terms. So in this case x is actually worth x, y is actually equal to y, but z in this case is equal to ln xy. So it's just, I'm just creating a placeholder to make it easier to explain. So we keep x times we keep y, and then we differentiate ln xy. So there's a table, you can find it on Google, for the differentiation of natural logarithms, e's, or so forth. The differentiation for a natural logarithm is 1 over the thing inside, which is xy, times, it's a chain rule, so xy differentiated, so differentiation of xy, which is a product rule now, right? It's a different monster, this question. So xy, how do we differentiate xy using a product rule? Because this actually should be the d by dx of xy. So let's, you know what we'll do, we will differentiate it. So what we can do, xy times product rule on xy, we'd keep x, we differentiate y, which would be dy by dx, plus we differentiate x, which would be 1, and we keep y, like that, right? That's one whole portion. Next, we can differentiate, use the second portion of the differentiation, xy prime z. So how do we do this? Plus x y prime, so not y prime. How do we differentiate y? Well, d by dx of y is just dy by dx, and then we can keep z as it is, so ln xy. ln xy. See, differential calculus is not anything too hard, right? The major thing is the algebra. The algebra can be complicated. And then finally we have to do the last portion, x prime y z. So let's differentiate the first one. So d by dx of x is just 1 times y ln of y, or ln of xy, sorry. So this is our total term differentiated, right? It's massive, but we can simplify it, and it is doable to make it look like that at the end. So if I can just zoom out a little bit. Okay, so how do we go forth for here? Well, let's simplify. We know that d by dx of x is just 1, so we can rewrite this. Dy by dx is equal to 1 minus, right? Let's make a big bracket and let's simplify. xy, these two get cancelled out, and so in this bracket we're left with dy by dx of x plus y. That's what we're left with in this bracket. Okay, then here, next portion, we get dy by dx of x ln of xy, simple multiplication, and in the last bracket we're left with y ln of xy. Now what do we do after this? We still need to make it look like this, but right now it looks nothing like that, right? So what do we do here? Okay, let's go forward. Let's try to make it even more simple. Now how do we do this? By taking out some common terms. We can see between these two guys there's dy by dx times x is common, right? So let's take that common. We can say dy by dx of x, and within the bracket we can say, if we take it common, I'm lost here. 1 second, I need to take some time to just see what's going on. So okay, plus y. Okay, so let's actually, before I do that, right, let's make it even simpler to the eye, because it looks confusing. Even I got confused what's happening. Let's group some terms together. Let's group the terms with dy by dx together, and then group the terms with y together. So this becomes dy by dx of x plus dy by dx of x ln of xy plus y ln of xy. Now all I did was group the like terms together, because that makes it easier to simplify, because as you saw just a few seconds back, I got confused with what's going on. So then we can say it's equal to, let's take out what's common, right? Between these two terms, dy by dx is common, so let's take that out. Dy by dx of x 1 plus ln of xy, that's common, right? And then here in this second term we can take out y common, so that becomes plus y 1 plus ln xy. Oh wait, do we see something familiar going on? We can factor this one further, right? We can take out 1 plus ln xy, because that's common between both these terms. So now that becomes, in a big bracket we can say 1 plus ln xy, this is one term, times dy by dx of x plus y. That's your second term. And now it's looking a lot closer to our final thing that we want to show, but of course this is still not it, right? So now we got this middle portion to look. So you can see, if you compare this section and this, that's the same, but this and this are not. So let's change that up. We need to say that 1 is equal to some expression. So let's shift the 1 and dy by dx. So this essentially becomes -1 is equal to negative dy by dx minus, in the big bracket we can say, actually we don't even need a big bracket, we can just, actually let's use a big bracket, 1 plus ln xy, ln xy times dy by dx of x plus y. This thing for the whole thing. Okay, so now we need to make sure there's no negative, because we don't want a negative in this case. It all has to be positive. So we can just factor out a -1 from both sides. So that finally equals to 1 is equal to dy by dx plus 1 plus ln of xy times dy by dx of x plus y. And let's see if I've done everything correctly. Is this our final answer? 1 is equal to dy by dx plus, exactly, that's it. That's your final proof. We have proved that this equation is possible. Now, that was a long process, and that's just for 3 marks. So let's go on to the next portion of the question, shall we? Let me just zoom out a little bit. We can see everything. Zoom back in a little bit. Okay, so we've proved that. Next portion, part Z. Let me just copy paste that, right? Okay. Part B. Hence, find the equation of the tangent to C at the point where x is equal to 1. Well, in this case, right, when we differentiate this y is equal to x minus xy ln xy, when you differentiate that, the term dy by dx is the tangent of this equation. But as you can see in our proof, the dy by dx is not isolated. We need to isolate this dy by dx, meaning we need dy by dx is equal to some term. Now, how do we do that? How do we get it that way? Okay, let's do this. How can we do this? Take a moment, think about it. Okay, let's try. We need to get dy by dx alone, right? So what can we do? Okay, what we can do, let's rewrite our equation. 1 is equal to dy by dx, and let's expand this multiplication. Okay, so we get dy by dx of x. So it's just FOIL method, right? This times this, this times this, this times this, and this times this. So dy by dx, let's put this in a bracket so we know what's going on. Dy by dx plus y plus dy x dy by dx system, not confuse anything, ln of xy plus y ln of xy. I'm just distributing the terms throughout each other. Now, why is this important? Because I actually want to get dy by dx alone. So let's go further. Let's simplify this further. Let's group all the dy by dx's together. So we get 1 is equal to dy by dx plus dy by dx times x plus, let's get all these terms together, group the like terms. So we get dy by dx x ln of xy plus y ln of xy. Now we've grouped all the terms together, haven't we? Now we can actually factor out a dy by dx from this equation. So let's do this. 1 is equal to, if we factor out a dy by dx, and then we get inside this thing 1 plus x ln of xy, right? That's inside one bracket, and then here we get y plus y ln of xy. Now, before we can isolate this dy, we need to shift this whole term to the other side, so subtract it from both sides. So we get 1 minus, let's put this here, y plus y ln of xy, right? This thing, and then if we then divide this term by this, right? If we divide this by this, we get 1 plus x ln of xy is equal to dy by dx. Now we've isolated our dy by dx, it's alone. Okay, this is actually our slope. This is the slope of our equation. Okay, so what do we do from here? Well, we know that the slope, this is just the equation of the slope, not the slope, sorry. This is the equation of slope. Now that we found the equation of the slope, let's find what is the slope, right? This is just an equation. We need to substitute a value for x and a value for y so that we can see what is the curve, what is the slope or tangent at this particular point. The value for x that they've given us is x is equal to 1. So we know we can substitute that in. But what is y equal to? How do we find out y to substitute into this equation? Well, we have an original equation right here. We can substitute x into here and then equate or calculate what is y equal to. So let's do that. Original equation, original x is equal to y is equal to x minus xy ln of xy. That is our original equation, isn't it? Yes. Let's substitute x is equal to 1, so y is equal to 1 minus y ln of y. So now, how do we solve this? Remember, this is a paper 2. We don't need to go through the troubles of actually solving for y here. Let's just use our GDC, graph it. So using GDC or graphic display calculator, GDC, we get that y is equal to 1, right? I just graphed it, and I'll throw in a picture of Desmos after this when editing to show you what the graph looks like. So we know y is equal to 1, and we know the coordinates of this point, which is x is equal to 1, y is equal to 1, right? So that's the coordinates of this particular point. So we need to find out what is the tangent at this point. So how do we do that? First, we need to find the slope because we did it in the form y is equal to mx plus c. So let's find out the slope. Dy by dx, which is what we calculated earlier, is equal to, and let's just paste that in. This is actually what it is equal to. Select. That's what dy by dx is equal to. Now if I substitute in all the known values, I get dy by dx is equal to 1 minus 1 plus ln of 1 over 1 plus 1 plus ln of 1. Now what is this equal to? Well, you get 0 on the top over 2 on the bottom, and that just equals to 0. So the slope of this particular point is actually equal to 0. That's the slope at this particular point. Now in the y is equal to mx plus c, we know what is m equal to, but we need to find out what is y equal to. So how so how will we find out what c is equal to? Let's just substitute all the values. We just know what everything is. We know 1 is equal to 1 is equal to 0 times c is equal to 1. So the value for the tangent is equal to y is equal to 1. That is the value for the tangent, because we're just substituting all the values we know. So y is equal to 1.